Most of the solutions in the laboratory are all labeled with known concentrations. Do you know how they are prepared? Let's find out. At the end of this lesson, students should be able to describe methods for preparing standard solutions. Describe the preparation of a solution with a specified concentration using dilution method.
Why do scientists or chemists have to know the concentration of the solutions they use? Did you ever notice that different bottles have different labels of concentration? From the labels, we will know that the solutions have their own exact and specific concentrations. What is a standard solution? A standard solution is a solution in which its concentration is accurately known. Its concentration is usually given in mole per cubic decimeter. Now that we know what a standard solution is, let us prepare a 100 cubic centimeter of 2.0 mole per cubic decimeter sodium hydroxide solutions. First, calculate the mass of solute needed. Key in your answer and click the check button when you are done. To prepare the solution, weigh 8.0 grams of solid sodium hydroxide using an electronic balance. Add 25 cubic centimeter of distilled water into the beaker containing the sodium hydroxide. Stir the mixture well to dissolve the solid. Pour the solution from the beaker into a 100 cubic centimeter volumetric flask through a filter funnel. Rinse the weighing bottle and the beaker with a small amount of distilled water. Pour all the washings into the volumetric flask. Repeat this a few times. Rinse the filter funnel with a small amount of distilled water. Allow the washings to flow into the volumetric flask. Remove the filter funnel from the volumetric flask. Pour distilled water into the volumetric flask until the meniscus level of the solution is exactly at 100 cubic centimeter calibration mark. Close the volumetric flask tightly with its stopper. Then, invert the flask several times to ensure thorough mixing. Now, your standard solution is ready. We have learned how to prepare a standard solution. Now, let's investigate what happens to the concentration of the solution and the mole of solute during dilution. Let's take orange juice as an example. What happens to the orange juice when water is added? We can see that the volume of liquid inside the glass increases. But what happens to the color of the orange juice? Can you guess what happens to its taste? Water increases the volume of orange juice in the glass, but its number of moles still remains constant. Therefore, the concentration of the orange juice decreases. That's why its color becomes paler. This process is called dilution. In the dilution process, solvent such as water is added to a concentrated solution to obtain a more diluted solution. The basic principle of dilution is addition of solvent does not change the number of moles of solute in a solution, but changes the concentration of solution. We know that number of moles of solute is equal to the product of molarity and volume of the solution. Since adding water does not change the amount of solute, Therefore, moles of solute before dilution are equal to moles of solute after dilution. We obtain the relationship for dilution, that is M1V1 equals to M2V2, where M1 equals to concentration of solution before dilution. V1 equals to volume of solution before dilution. M2 equals to concentration of solution after dilution. And V2 equals to volume of solution after dilution. Now, let's prepare a 100 cubic centimeters of 0.2 mole per cubic decimeter sodium hydroxide solutions. Before we begin our lab activity, let's calculate the volume of 2.0 mole per cubic decimeter sodium hydroxide needed for dilution. Calculate the amount of 2.0 mole per cubic decimeter sodium hydroxide needed for the dilution. Key in your answer and click the check button when you are done.
Try again.
We need to dilute 10 cubic centimeter of 2.0 mole per cubic decimeter sodium hydroxide solution with distilled water in order to prepare a 100 cubic centimeter of 0.2 molar solution. Now, use a 10 milliliter pipette to draw up 10 cubic centimeter of sodium hydroxide solution. Transfer the sodium hydroxide solution to 100 milliliters volumetric flask. Add distilled water into the volumetric flask until the meniscus level of the solution reaches the 100 cubic centimeter calibration mark. Close the volumetric flask tightly with its stopper and invert the flask several times to ensure thorough mixing. Our solution is now ready.
How do you prepare a standard solution? There are 5 steps involved. Arrange the steps accordingly. Drag and drop the steps to the blank spaces provided. Then, click the check button. Well done!
Click on the blinking button to proceed.
Calculate the molarity of each solution after dilution. Type in your answer in the given boxes and click on the Submit button once you have completed the activity.
Try again.
In this evaluation, you will be tested on your understanding of. In this lesson, you have learned that a standard solution is a solution which concentration is accurately known. Volumetric flasks are used to prepare a standard solution. Steps involved in preparing a standard solution are: calculate the mass of solute needed, weigh the exact mass of solute needed, dissolve the solute in a small amount of distilled water, transfer the dissolved solute into a suitable volumetric flask, add enough water until it reaches the calibration mark on the volumetric flask. Steps involved in preparing a solution by dilution method are: calculate the volume of stock solution required, pipette the required volume of stock solution into a suitable volumetric flask, add water until it reaches the calibration mark on the volumetric flask. In conjunction with the Science and Mathematics Carnival, your class decided to enter a sketch competition. Prepare a role play to show the dilution process of a standard solution. Practice with your group members. Present your role play in front of the whole class.